Okay. So from here, what we're doing is we're setting up this left Riemann sum. Notice how the left upper corners are all touching right here, here, and here of each respective rectangle. You with me? All right, here we go. This first rectangle that I'm going to highlight in green, actually I'll do it in like black. This right here, Braden, what's the base?
The base is 3.
3, perfect. And you could get that from seeing the jump that occurred on the x values. You with me? What is the height of this first one? Right here, because listen, because of the fact that it's a left endpoint, or sorry, left Riemann sum, we want to look at the left height. You with me? Not the right height. The right height is too big. And I'm only looking at the first rectangle. So the left height is going to be anyone, what? 30. Okay, let's go to the second. The second one, let's do this one in purple. Matthew, what's the base of that one? It's still 3, right? Because the jump from 3 to 6 is 3. Arjun, what's the height of that one? The second one, yeah. 37. If you didn't choose 37, Arjun, what would you have said? What's the only other number that you could have said? 45. But we don't say 45 because we're doing a left Riemann sum. So we want to look at the left side height. Okay? All right, so everyone, what's the next height? 45, the last height? 54. Notice on the left, we didn't use 65. Just like on the right, we're not going to use what number? 30. You with me? Okay? So you could put 30 plus 37 plus 45 plus 54. And this right here, be handy with the calculator because you will need the calculator, especially for the group bonus points we're going to do in about 15 minutes. What is the answer for that? Say it out loud. 498. Right? So here's the thing. Braden would almost get full credit. 498 is almost the answer. What did we just do? We just found the area underneath the curve. We integrated. We anti-derived. We're going up from the dream. And this is where we were at. So when we integrate,
So it's going to be 498
feet. So 498 feet is what was traveled. Cool? That's your answer. Don't forget that, especially for group bonus points, okay? The right Riemann sum. You'll do R sub 4. Here we go. And the right Riemann sum, first of all, before I go to the right Riemann sum, guys, what we just did, is it the actual answer to the full green area underneath the graph? No, you're going to have those little pieces. So you tell me, is it an under or an over approximation?
Under.
It's an under approximation. Here we go. For points. Because what?
Because
Do not describe a graph to me.
it's a left Riemann sum.
You could say that you started off like that.
Because you're leaving out the point table.
It's a left Riemann sum on a what function says that it will be an under approximation
Positive velocity.
on an increasing function. You with me? So if the function is increasing, either concave up or concave down, it doesn't matter. You with me? If I do a left Riemann sum on an increasing function, it will always be what? An under approximation. Okay? So the way I want you to do it, and I'm not kidding, I want you to just say that it's increasing, but also describe the concavity. I want you to, because of other things that I want you to associate with later. Okay? Do you need the concavity? No. As long as you have the increasing, but please show up. Yeah?
If you had like a function where you could have like a perfect triangle, then it would be the exact area.
True? Yeah?
But you would use a trapezoidal.
you would use different things. You could still, we're almost there. Okay, we're almost there. Let's do, okay, real quick. Right Riemann sum. Will a right Riemann sum with the same points be an under or an over approximation? Over. Because it's on an increasing function and it's a right Riemann sum. Visually, it looks like this. There's that first one. Here's that second one. Here's this third one. And here's this fourth one. Because a right Riemann sum on an increasing function is going to basically go over the function. And you see that this over approximation is like these little pieces of excess. Are we good? Okay. So, mathematically, what is it that I want you to write over here when you have r sub 4? 3 times
37 plus 45 plus 54.
Perfect. Handy with the calculator?
603 feet.
603? Nice. Cover on that. Feet. That's the accumulation of change. You with me? Alright, so here we go. Midpoint and trapezoidal. One of these is the average of these two answers. So if I take 498, please do this for me in your calculator, 498 plus 603, and divide that by 2, what do I get? 550?
Yeah.
550.5. One of these, okay, so we have a trapezoidal left or a midpoint left. Which one do you think will give me 550.5? That's what a lot of people think. It's trapezoidal. Can someone tell me why?
Well, because I think trapezoidal would be more accurate for this set of data, and that seems in between the under and over approximation, so it'd be more like the actual.
I don't see
Right
a
answer.
trapezoid.
Okay, I'm going to show you in just a bit. I'll show you. Yes?
Well, it's 'cause, like, in the formula for a trapezoid, you're taking base 1 plus base 2 divided by 2, and that would be the average
Okay.
between the left side and the right side of the trapezoid.
So here we go.
Or rectangle.
You got it. So let's go with orange. If I'm looking at this specific one, that's a right Riemann sum. And if I looked at this same one, that's a left Riemann sum. And if I average those, what shape would I have between these 2 points? Or what would be between those 2 points?
Line.
A straight line for the average, right? So the straight average, the halfway point, it's like taking half of the over and under, and I'm creating the trapezoid. You see the trapezoid now? Okay, so the trapezoid is this. What is base 1 and base 2? The left and right y values. You with me? So you're basically rotating, like if you had a B1 on top, you had B2 on the bottom, you're just taking this, and what used to be a height, ooh, that's not going to let me rotate it. What used to be a height is now going to be the base, a delta x, the width of that rectangle. Okay? So the trapezoidal, I'll take the average of the y's and multiply it by the base. You with me? Let's do the first rectangle. What plus what divided by 2 for the first rectangle?
30 plus 37.
30 plus 37 divided by 2 times what? 3. Now I'm going to take the 3 out because they're all 3. Okay? What's the average of the second y's? Come on, guys.
37 plus 45.
Yep, 37 plus 45, right? And these are adding together. What's the trapezoid equation that will show my average height for the third one?
45 plus 54.
45 plus 54 divided by 2. And then the last height would be what? 54 plus 65. Are y'all with me? Do y'all understand? So the average of the y's times the base, all added up together, is going to give me the trapezoidal sum. Cool? A lot of people think it was midpoint though.
What would midpoint look like?
So midpoint, here's the thing. Midpoint doesn't go off the average of the y's. It goes off the average of the what? Of the width of the x values. Okay, so here we go. I want you to concentrate. Let's pick the third rectangle on the graph. We're going to do a midpoint formula. The left x value is 6. The right x value is 9. This is the midpoint, and it's the most annoying one because it requires a lot of steps. Is I have to find the halfway point between those. How do you find the halfway point between two numbers? Add them and divide by 2. You with me? What's the halfway point between 15? 7.5. So 7.5, guess what I'm going to do?
Take the y value.
I'm going to find the y value on the graph, and this is my height. Great question. On this one I can't. On another one in just a bit I'll show you can. Okay, here's the thing. Nicely done. Okay, so in midpoint you need a function to do this, or instead of 4 rectangles, what if I had 2 rectangles?
Just split at 6.
The first one would have a width of 6. You with me? The second one would have a width of 6. And you tell me, what's mid between 0 and 6? 3. What's the y value at 3? 37. So it'd be 37 times 6 for the first one. Because a midpoint looks like that. You with me?
Yes.
And then the last one would be still width of 6, but the height would be 54 because the midpoint of 6 and 12 is 9. Are we good? Do we understand? All right. So to sum it up, and then we'll do a group bonus points. This is a good visual, okay? Left Riemann sums will look like this. Right Riemann sums will look like this. Midpoint Riemann sums will look like this, because you are looking at base times height to get that area. You're looking at base times the right height to get that area. Does this make sense to you guys of what I'm doing? And this average of the x's, the midpoint between these two, if I get a y value, this is my height and this whole thing is the base to get that area. And then the trapezoid is just the equation of a trapezoid. Okay? So when you have that trapezoidal, you have, this is y1, this is y2. This right here is your like delta x, otherwise your base. And you can say average the y values and multiply it by the base. You could put b there or delta x, because that will give you all of this.
So that problem of adjusted, the trapezoidal is the one that's the most accurate because of the shape of the
Yeah.
area.
Yeah. And because of the fact that, okay, here's the thing. The most accurate one. All of these are exact approximations. They're exact numbers, but they're approximations. They're not the answer. So here's the culmination for the day. How could I get the exact answer? With no over approximations and no under. You're back in kindergarten and you shade just in the lines perfectly. What would you do?
Use the calculator.
No, not, okay, you can use a calculator, but what's important about what we've been doing with, like, the graph?
Just thinking like,
This is 200 points, by the way.
just cramming in as many rectangles as you can, and then
How
having,
many?
like,
I need a number.
There's
yeah,
instant.
infinite number.
I like you jumping on that. Yep, infinite is exactly right. So listen. Secant, average rate of change. Y2 minus Y1 over X2 minus X1. Remember? We used to call this H. Do you understand? I know it's been a while. Remember this? So if this right here is H, come on, computer. This error between the X values, like X2 minus X1, if that's H, what did we want H to approach? So that I didn't have the secant, but I had the instantaneous rate of change. 0. So you're getting a lot of points. So back when we did this, we wanted this value, well, that was ugly, to approach 0. Because if that can approach 0, and we get that to be smaller and smaller and smaller, well, that's going to be weird. We're going to have it converge to 1 point, which is that instantaneous rate of change. You with me? So it's infinitely getting smaller. Robic is exactly right. What we want on these is for their widths, otherwise that change in x, which you're going to see the denotation of dx. Remember when we did this all with derivatives? Now we're going to do it with integrals. This dx is representing that width of a rectangle. And what is that going to do? It's also going to approach what? 0. By having how many rectangles? Infinite rectangles. You with me? So guys, if I go back over here and I show you, I want to have an infinite rectangle. Infinite rectangles. Can you tell me what is the width of the first one?
You can't.
It's not 0.
I have no idea. You can't.
It's so small, let's say that it's the width of a hair. So if I drew that, it'd be a hair. Oh, that's too thick. All right, so you know what I mean. So there's the hair. It's still too thick. Nothing changed. Sorry, my bad. But my point is, it's real, real thin. Imagine it's thin, okay? I don't know what's going on. All right, so the next one, thin, 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 thin. You know what I'm saying? Infinite ones, you will not have any extra excess over approximations, nor under. It'll be exactly the answer. Just like the secant becomes the tangent, this approximation becomes the exact area underneath the curve. Because we don't have an equation per se that has irregular shapes like this. So we're integrating. We're going to do a lot more of this in other ways. We good? So on your notes, what I want you to do is the next one for bonus points. I want you to do all 4. I want you to show all work in your notes, but I will give you a pink sheet of paper that you're just going to give me the answer with units. And you have until the bell rings to give me all 4 answers. If it's perfect, I will double your score. Units, units, units.